So I'm going to present some stuff that my colleague John Badley, who'd done the other roadshows earlier in the last week, he can't make it today, so I'm covering for those. I'm going to be talking about cover crops and green manures. Why should we be interested? Well, broadly defined, cover crops are grown for benefit of the soil. Some farmers already use them, and obviously they're highly linked into the cap greening regulations, particularly in terms of the ecological focus areas. And the elements that I'm going to be talking about primarily are the nitrogen fixing crops, the catch crops and the green cover crops, which are the bottom section here. In terms of EFA rules, this map here, anything that's blue there is the national arable area, of which roughly 5% of eligible businesses must have some form of EFA in there. So going back to the green manures and fertility building crops, this is a picture of crimson clover, which was grown a couple of years ago at the site that we've got at Suffolk. There's a range of advantages if you grow these things correctly. So things like adding organic matter, increasing biological activity, improving soil structure, etc., etc. Suppressing weeds is a possibility as well. Reduce pest and disease problems. And because I'm going to be talking more about the nitrogen fixing green manures, there's going to be that carryover effect in terms of soil nitrogen levels, which hopefully will lead to decreased need for bagged fertiliser costs in terms of cost and also pollution savings. Disadvantages, well, obviously you've got extra seed and extra cultivations included. There's a lost opportunity for cash cropping, depending on where you squeeze these things into your rotation. Extra work as well at busiest times of years, and you may actually increase pest and disease problems as well because of the green bridge effect. And the green manures themselves could become weeds, and although you may have N-fixers or the legume component, that nitrogen isn't necessarily going to be available when the following crop requires it. There's a few things. These things that are coming up in red have changed this year. So red and white clover is now specified. Before it was just clovers. So that's very specific. This has remained the same as well. In terms of EFA nitrogen fixing crops are surrounded by a claimed EFA field margin. So that kind of implications in terms of how you manage the thing, particularly if you look at grazing after August. The fact that you can now have mixtures is also new, which is actually quite a good thing, because that can add a load of benefits in terms of the efficiency of the system. This has remained the same. No more than 75% of the total area must be one crop. And this is another thing here. You cannot use plant protection products before the 1st of August. It has a whole range of implications in terms of things like herbicides, etc. And this is to protect ground nesting birds. So that's kind of the background, the kind of context to where the research that we're looking at comes into. So some of the drivers for the work that we're doing at SRUC on green manures are linked to partly to these CAP reforms, greening regulations in place, but do they deliver the intended benefits? Andy mentioned some of the pollinator type work. So the plots that I will be talking about here, Lorna has done some measurements on the biodiversity and the insect visitations and what have you in terms of above ground biodiversity. And it's part of the Scottish Government RESAS programme, the current one, which is in its 3rd year now. And there's a track record of intercropping, mixtures and organic and biodiversity work, which ties in very strongly with the use of green manures. So the research aims assessing the agronomic, environmental and economic performance of a wide range of cover crop species at 2 sites. The picture here is of the Aberdeenshire site, but there's also a sister site down in Midlothian, the Bush Estate. So this is replicated small plot trials over multiple years, so we're currently coming into the 3rd year of these. We're also interested in multifunctionality, so we're interested in them as a green manure or cover crop, We're also looking in what if you were growing them as a crop with a value in its own right. So we're looking at things like silage quality of some of the materials that we're producing. Also, we've got another link into work with the Rauer Institute, where they're looking at extracting protein from the material that we're growing. So we're looking at other benefits beyond just kind of the soil qualities as well. And also practical recommendations, but we're still a wee bit off giving a huge amount of information on there, but we're kind of building up to that at the moment. And also informing Scottish Government policy. So those red words that popped up on the previous slide, some of those will have changed based on feedback from this and similar trials that are feeding into the panels that change these rules or guidelines. So what we've been growing, or have been growing, is a list of all the straights on the list, except lentils and chickpeas in this particular trial. We have tried growing lentils in a different trial, which looked like it had some capacity for silage, but certainly not grain. But of the ones in here, we've got 5 three-way mixtures of these straights as well, for various elements. So we're looking at mixtures with contrasting genetic and functional diversity. So on the left-hand side here, we have a mix of 3 clover species, which are all fairly low down to the ground, sort of entwined. And on the right-hand side here, we've got a clover bean vetch mix. So what we're trying to do here is use the beans as a big support structure and try and get a 3D structure in there. And this is particularly was designed for the pollinator, to try and encourage a wider range of pollinator over a longer period of time, as over the season as possible. So why grow mixtures? Well, we've got evidence, and there's quite a broad range of evidence that mixtures are quite efficient in terms of utilising not only your soils, but also all the other resources, the sunlight, rainfall, etc. And you typically would get somewhere in the region of 20 to 40% higher than if you just grow individual species on their own. So they're good in terms of efficiency of your system. You've also got this built-in redundancy, so that if one of your crops fails or struggles a little bit, the other one will tend to compensate. So again, you're getting some benefit in terms of biomass and hopefully quality as well. So there's resilience there to adverse conditions, and we know what the weather can be like, or has been. You get some pretty adverse conditions, so having that built-in redundancy is a useful factor. Some may be suited to other purposes, so perhaps high protein silage or protein extraction, which could be utilised for human use, but that's another story. But we're looking at these alternative uses, particularly high protein. And also, Andy's already talked about some of the biological biodiversity benefits. So having a mixture there with different species, different niches, you can allow it extends basically the period that pollen is available, which is useful, given the extra yield that is associated with pollinations. In terms of this graph here, anything in red is a mix, anything in green is a straight, and this little one down here, this is just grass and clover. It's grass and white clover in this one here. This is really just first cut yield, mid-season, just to give an indication of the amount of material that's being grown. And you can see the mixtures are all on the right-hand side, so they're all providing bigger amounts of material. And these ones here are the grain legume mixtures. So mixtures generally producing more material, and the grain legumes are producing the most of all of them. Linking up to the fact that we're looking at nitrogen fixation and what's going on, we've got a control treatment here where we had spring barley growing the previous year. This is pre-ploughing before we put spring barley in again last year. We've got forage legumes in this column here, so obviously the nitrogen input was there. It was probably about 10 kilos per hectare greater. at this point in time. The grain legumes, again, slightly higher again, and the mixture of grain legumes and forage legumes again. This was taken pre-ploughing, so it was relatively cold. We'd expect, as the season warmed up, that you'd get more mineralisation. There'd be more, actually, these would get expanded or exacerbated, these kind of differences. So there'd be more, much more available nitrogen to the following crop. And say in this instance, it was a spring barley crop. We haven't got all the data for that yet, so unfortunately I can't present that, but we would expect to see the mixtures on the right-hand side, or the barley that was growing on those plots, to have a better yield. So in summary, nitrogen fixing crops can offer a good route to meeting cap greening rules, and they can certainly tick a lot of boxes for the EFA and diversification. So a wide range of nitrogen fixing crops have been grown successfully on much of Scotland's arable land. You can have problems, but there's an awful lot that will grow quite well. And from 2018, mixtures, which is now part of the EFA angle, can be grown, so there's potential to maximise the use of the efficiency that you can get from growing these mixtures. Certainly in terms of soil mineral nitrogen for the following year. And there's another range of other aspects as well linked to them in terms of kind of soil structural type work. So again, there's a continuation of this work. So unfortunately, I haven't got the data to be able to provide that, but maybe next year it'll filter through at some point for the following cereal crops. But that's it.